Hello everyone and welcome to another episode of Investigation. In today's episode of Investigation, we'll go over number 11 on the 2023 AMC 10B. And before we get started, I highly encourage you, if at any point you do not understand anything I say in this video, please put them down in the comment section below, or if you have any other totally different questions, feel free to put them down in the comment section and I will be able to help you. Anyway, let's get started. It says, Suzanne went to the bank and withdrew $800. The teller gave her this amount using $20 bills, $50 bills, and $100 bills, with at least one of each denomination. How many different collections of bills could Suzanne have received? So here we kind of need to simplify this problem into something concrete that we can work with. So let's say there are X $20 bills, Y $50 bills, and Z $100 bills, and 20X plus 50Y plus 100Z is going to be 800. And we know that X, Y, Z are natural numbers. This just means that X, Y, Z are natural numbers. We can feel free to divide both sides by 10. So that makes the problem a lot easier. And we can do this by saying, oh, we can have this 10Z. We can fix this 10Z. Let's say, first of all, if Z is 1, if Z is 2, 3, 4, 5, 6, 7, all the way to if Z were to be 8. And if Z is 8, the other two has to be 0, so that doesn't work at all. And so the amount we have left, so after each Z, we have the amount we have left, so that's 2x plus 5y. This is equal to 70. And for Z equals 2, that's 60. For equals 3, that's 50. For Z equals 4, that's 40. For Z equals 5, that's 30, 20, and 10. And we want 2x plus 5y to be equal to that. And you can find just a simple solution here. X and y. Just tell me a solution in your head. What is one integer solution for this pair? I will say x equals 35, y equals 0. Or we could have x equals 0 and y equals 14. And be careful here because 0 is actually not allowed. Because the 0 we have over here actually is something that's, if we take a look at the original question, we need at least one of each denomination. So 0 is not actually allowed. Therefore, we want to eliminate this choice. And what other answers are there? The other answers, if you think about how to make this 0, we want to find the similar solutions such that 2x plus 5y equal to 0. If we have solution to this and we know at least one solution, then we can just add this much x into one of our equation and add this much y to one of our equation to generate all of the other possible solutions. So this, the smallest x and y we could have is the smallest absolute value, I guess, for x and y is x is 5 and y is minus 2. Of course, the other way works as well. So the other solutions can be generated by, over here, 0 and 14 we have over here, and this plus 5 and this minus 2 repeatedly. How many solutions are there? We see, well, minus 2, 12, minus 2, 10, minus 2, 8. You see, this process sounds like division, and that's exactly what it is. And we want all of the ones, so 14 minus 2y is greater than 0, and actually 14 doesn't work as itself, so 2y is less than 14, so y is less than 7. So this y, as in, let me use another variable, I guess, because that is not y itself, equal minus 2k, then k is equal to 7. K is the number of 2's we subtract from y. Then we would have 1, 2, 3, 4, 5, 6. When k is that generates for each k exactly one solution of x and y. So we would have 0, 14 doesn't work, 5 and 12 does, 10 and 10 does, etc. If you just put have x equals 0 plus 5k and y equals 14 minus 2k, then 2x plus 5y is always going to be equal under this condition. How many k's we have? We have 6 k's. So we have 6 cases, possible cases over here. And now let's consider how about 60. Now that will be easier. So let's just think about what we concluded. We concluded that this 14 over here is 70 divided by 5. So we do 60 divided by 5. 0 and 12 is one solution if we disregard the at least one such currency condition. Then 0 and 12 is one solution over here. And if you, again, it's the same thing. You subtract 5 every single, you subtract 2 from y every single time. And that actually brings you to 12 minus 2k is greater than 0. So 12 is greater than 2k, and k is greater than 6. So here there are 5, because 1, 2, 3, 4, 5, remember 0 and 5 doesn't work. And the next one is 0 and 10, the next one is 0 and 8, next one is 0 and 6, 0 and 4, 0 and 2, and how many different solutions for each of these there are? That's 4, 3, 2, 1, 0. Pause the video and ponder yourself why that is true. And if you don't understand, again, comment section will be of great help. And if we just add these up, that is the total number that we're looking for, which is 21. And that is our answer choice B. That is it for number 11 in 2023 AMC 10B. And I hope to catch you in the next video. Again, in the description, you will find the notes for this problem. You do not have to take screenshots when I'm zooming around. It's kind of hard. So I provide a PDF version of the notes. But for now, farewell, and I'll catch you in the next one.